Hi there, folks. Today we're looking at properties of logarithms. And once again, when you think about logarithms, a logarithm is just the inverse of an exponential function. And so when you think about that, when we kind of focus in on properties of logarithms, well, let's think about the properties of exponential functions, more specifically the rules of exponents. You know, we have these special rules that when you multiply, we know that we're supposed to add the exponents. When you divide, you subtract the exponents. When you raise something to a power, you multiply the exponents. And when you take a root, you divide the exponents. And so as you think about those rules, that's the rules for exponents. Well, the rules for logarithms, the properties of logarithms, are the same things but in reverse, okay? And so as we look at this first one, the product rule for logarithms, here's what it says. Notice we have two logarithms being added, and it becomes one logarithm with multiplication in it. I went from addition of two things to multiplication, x times y inside the logarithm. And so when you think about that, again, the rule for exponents is when I multiply, I add the exponents. But the rule for logarithms is the reverse. When I'm adding logarithms, I change it to multiplication. Okay? And so that's the idea here. Now, granted, over here, we're just saying, hey, we could do that rule in reverse if we wanted to. If I had multiplication inside this logarithm, I could split it back up. Okay? It is rare that we need to do that. Really, the rule, the way we normally use it, and the way it's used most of the time is like this. Okay? If I have two logarithms being added, I can rewrite it as one logarithm with a little multiplication inside. All right, it's the same rule that we had for exponents, but kind of reversed. Exponents, it was, hey, multiplication becomes addition. Well, now for this one, it's addition becomes multiplication, okay? And one of the keys here is we have to have the same base, just like we did with our rules of exponents. With rules of exponents, if I have an x to the third times a y to the third, well, I can't do anything with that because they don't have the same base. Okay? So likewise here, I have to have the same base. I have to have the same value down here in order for this rule to work. Okay? For example, if I look at this first one, it says write each as a single logarithm. And so I'm using this property that says, hey, addition becomes multiplication. So right here, I have log base 2 of 7 plus log base 2 of 6. Well, the property of logarithms just said, hey, I can rewrite that as one logarithm. So log base 2 of, well, it becomes multiplication now. So addition becomes multiplication. So instead of 7 plus 6, I do 7 times 6, which is 42. And see, there's a couple advantages to doing that. I'm not going to simplify that any further. I'm going to leave it as a logarithm because that's what the question asked for. But really, when you think about that, that's going to be a lot easier to plug into the calculator if we wanted to calculate that value. But also the idea of combining things into one thing, all right, to kind of reduce this into one value, into one logarithm, that is a common theme that we see when we're solving equations. And so this is, one, going to help us make this a little bit simpler in terms of plugging values in and getting values out, but it's also going to help us kind of condense this thing down to one logarithm, which is ultimately going to play a role in solving these things. All right. If I look at the next one, same kind of thing. I have addition. Addition becomes multiplication. So it's log base 3. Notice the base stays the same, just like it did with rules of exponents. The base stayed the same, and I dealt with the exponents. Here, the logarithm base stays the same, and I just deal with what's inside the logarithm. Okay. Addition becomes multiplication for logarithms. So x times the 5x is a 5x squared. And that's it. If I look at the next one, once again, I have two logarithms being added. I'm going to combine that into one. And addition of logarithms becomes multiplication inside the logarithm. So I do some multiplication. X plus 1 times the x minus 3 is going to be an x squared minus 2x minus 3. And if you need to take that off to the side and do the x plus 1 times the x minus 3, distribute the x, distribute the 1, combine like terms, I'll go for it, okay? I just went ahead and combined the like terms in my head. All right. Likewise, kind of going the other way, if we ever need to do this, if I ask you to expand, it just means undo the rule. Undo the rule that said, hey, the addition of these two logarithms I could rewrite as multiplication. In other words, if I have multiplication, I could undo that rule, and I could undo that rule by splitting this thing back up. And if I were to split this back up, it would become log base 2 of 7 plus log base 2 of x. Okay? Because again, the rule is I have addition with these logarithms. I can rewrite it as multiplication. So the rule is typically this addition becomes multiplication, but if I need to, I can use the rule backwards, okay? And that's what this is saying. When I say expand, I'm saying, hey, use the rule backwards to split this thing back up, okay? It's rare that we need to do this. Most of the time, we need to combine things, all right? But every once in a while, we need to split things back up. Likewise here, I could say this one, I could split up into log base 3 of 3. I could split that, then it would be a plus log base 3 of x squared. But then x squared is just x times x. I could split that up even further into another x. Okay? And that's the other thing that's a little bit tricky in terms of expanding these things. When it comes to expanding these things, sometimes students don't know where to stop. Like for this one, how do we know to keep going with this? How do I know not to just leave this as an x squared? Okay? And eventually, what we'll do is we'll rewrite that x squared as something else. And for the purposes here, this would be a pretty acceptable answer at the moment. Okay? Really, it serves no purpose to continue to split that up in terms of addition. Okay? And so keep that in mind. There's a lot of different things that we kind of have to worry about here. Worrying about splitting it up enough isn't something we're overly concerned with right now. Once we get all of the rules, then we'll kind of break this down a little bit further. If we look at something like this guy, if you know any really old people that have used a slide rule in terms of simplifying logarithms, I'm sure I just insulted some math teacher somewhere. But if you know someone who's ever used a slide rule for calculating logarithms, this is where expansion becomes important. Something like this guy, a 21 is like a 7 times 3, which means I could split this up into a log base 5 of 7 plus a log base 5 of 3. And see, the idea is back in the day, you couldn't just plug logarithms into a calculator. You had to look up certain logarithms on a table of values, the decimal approximations, or using a slide rule to get the decimal approximations. And the slide rule didn't have, log base 5 of 21, but it did have log base 5 of 7 and log base 3 of 3 we'd be able to do, and then we could actually add those together by hand. Okay, so this kind of comes from an age where calculators couldn't do these things for us. So again, the rule, the way we typically use it is up here. Okay, addition becomes multiplication. If you can do that, you're 90% of the way there. Okay, every once in a while, yeah, we could maybe use this to split things up. Okay. Moving on to the next rule, the quotient rule for logarithms, okay? So back to exponential functions, the rule for exponents is that when I divide, I subtract the exponents. So the rule for logarithms is when I have subtraction, it becomes division. I use the same rule, but in reverse. Instead of dividing becomes subtraction, it's subtraction becomes dividing. And just like the previous rules, yeah, I could use this in reverse, okay? So if I need to. Again, this is kind of how we think of the rule. And yeah, if we need to use it in reverse, we will. But subtraction becomes division. That's the rule. That's the way we want to think of the rule. Okay? And so for this one, here I have some subtraction. That subtraction is going to become division. So it's log base 2. Well, instead of 24 and a minus 8, it's going to be 24 divided by 8, which is a 3. And there it is. That thing is simplified. And again, that would make it easier to plug into the calculator. It would serve a purpose in terms of solving these things. Okay? If I look at the next one, once again, I have subtraction, and subtraction becomes division, so it's log base 3 of. And, the order in which we subtract is important. Like here, it was x, and then we were subtracting the logarithm of the 5x. I have to divide in the same order, so it's just x over 5x, which reduces to 1/5. Okay? So it's x divided by 5x, which is 1/5. And notice, this thing simplifies quite a bit when I start to combine these things. Okay? The next one, likewise, same kind of thing. I'm going to combine this into 1, so it's log base 5. Subtraction becomes division inside this thing, and it's got to be x minus 1 divided by the x squared minus x. And then from here, I can actually simplify this guy a little bit further. If you think about this thing, that's x minus 1 over. Down here, I can factor out an x, and now the x minus 1's cancel, so it's a 1 over x. Okay? But again, that's a lot of simplification happening by using this rule, all right? Once again, it doesn't happen often, but we can expand these. We can do the rule in reverse if we need to. So like this one, I could split this back up and say, hey, I have division. I could split that back up into the subtraction if I needed to. Again, it's rare that we would need to do this, but here it is in case we need to, okay? Most of the time, we are using the rule as subtraction becomes division inside the logarithm. And yeah, any rule can be undone and can be done in reverse, okay? Even our rules of exponents. This one, same kind of thing. I could split it up. I could say, hey, this becomes log base 3 of 2x minus the log base 3 of 7. And then from here, I could continue to expand right here. Here's my other rule that I can expand upon. That's multiplication. I could split that back up into addition. And again, what purpose does this serve? It doesn't serve a whole lot of purposes. It's more useful to use the rule the other way. Typically, we want to write things as one logarithm. We want to use the rule that way. But yeah, we have to understand that, yes, we can use this rule in reverse, okay, if we need to. Same thing with this guy. I'm only going to simplify it to this point. I'm going to say log base 5 of x squared minus log base 5 of y, okay? And I'm going to leave it like that for now. Yes, that x squared is like x times x. I could split that up further. I could undo more, all right? But I'm going to leave it like that for now because we're going to learn one more rule that's going to help us simplify that a little bit easier. If I look at this guy, the power rule for logarithms, remember for exponential functions or rules of exponents, when I raise something to a power, I multiply the exponents, okay? But now here for logarithms, I have multiplication, and I rewrite it as an exponent, all right? It's the same rule, but in reverse. I had exponents become multiplication. Now I have multiplication becoming an exponent, all right? And that's the idea here. Right here, I have multiplication. It's times this r value. Well, that becomes an exponent inside the logarithm, okay? And this is the rule that's probably the trickiest for students to kind of think about. But it's also the rule that we will use the reverse, we will use the expansion almost as much as we use the original property, okay? So the original property, multiplication, becomes an exponent. Well, that just means if I want to undo this, an exponent inside here can become multiplication, okay? And, when we look at this, this is a rule that we will use in reverse a lot, okay? And the reason for that is because think about the things we've been dealing with leading up to logarithms. We've been dealing with exponential functions. And what happens is here, I'm dealing with an exponent, and that exponent is becoming multiplication. That has certain implications in terms of being able to solve and deal with exponents and exponential functions. And that's why this rule will get used in reverse more so than any of the rest of them, okay? So this one, I'm not going to just put it in a thought bubble. We're going to use that rule quite a bit in terms of doing it in the reverse, okay? So here's kind of what this looks like. Again, if I wanted to write this as a single logarithm, the rule is multiplication. The thing I'm multiplying by becomes an exponent. It's that reverse rule. So here, I'm multiplying by 3. Well, that 3 becomes an exponent inside the logarithm. So it's log base 3 of 2 to the third power. And of course, 2 to the third power is an 8, so I can just rewrite this as an 8. Okay? I don't have a lot of space, or I'd kind of write it in 2 steps, all right? But once again, that's going to be easier to plug into the calculator, a little bit easier than the original function that's here. But the greater, the thing that we typically use this for, as we combine things, as we can condense them into one thing, it's going to allow us to solve some of these things, all right? This guy, same kind of thing. Multiplication becomes an exponent inside the logarithm. So right now I'm multiplying by 4. That just becomes an exponent in this logarithm, so x to the 4th. And that's it, okay? The rule for exponents was, hey, exponents become multiplication. The rule for logarithms is multiplication becomes an exponent, okay? This one, same kind of thing. That becomes an exponent. So it's log base 5. I'm multiplying by a 2. Well, multiplication becomes an exponent, so it's going to become an exponent of 2 inside this logarithm. And that's it, all right? And yeah, you could maybe write this this way as well. You could multiply it out as x squared minus 2x plus 1. And that might be beneficial depending on the problem. Yeah, maybe I'd want to write it this way instead of this way, okay? It really depends on the context when we get there, all right? And now expanding each, with this section, again, we will use this quite a bit, all right? Expansion gets used for this rule more than any other rule because of the nature of exponents and the idea that when I take this thing from an exponent to multiplication, it has implications in terms of how I'll be able to deal with exponents in the future. Okay? And so keep that in mind. This is going to help us solve complex exponential functions eventually. All right? And so once again, this guy right here, I have an exponent. Well, I could rewrite that now as multiplication outside the logarithm, okay? See, multiplication became the exponent. I can work backwards and say, you know what? I'm going to change this back to multiplication. And there it is, okay? So multiplication becomes an exponent. Well, here I'm going to say, you know what? I'm going to rewrite this back as multiplication, okay? And now from here, I could expand this even more. The thing that's tricky is right here, this guy, if I wanted to expand this a little bit more using some of my other rules, this would become log base 3 of 2 plus log base 3 of x. But then what do I do with that 5? That 5 was being multiplied by this single logarithm. Well, that single logarithm became 2 logarithms, so yeah, I have to multiply that 5 times this entire thing, okay? And you could distribute that. You could put that 5 in front of each logarithm, or you can just leave it like this. Okay? This guy, same kind of thing. I'm going to say, you know what? Multiplication becomes an exponent, but I can work backwards, and I can turn that exponent back into multiplication. So here it is, back as multiplication. And then students get a little bit overzealous here, and they kind of go crazy with this. So they say, oh, x plus 2, I'm going to split that up. Well, you can't split that up. Okay? There's no rule that allows you to split up addition inside a logarithm. Okay? Multiplication, you could split back up into addition, but not addition. All right? If I kind of combine all these skills together, here's what it looks like. I want to rewrite each of these as a single logarithm. Just like when I use my rules of exponents, I have to follow order of operations. So when you look at this, here I have a couple operations. Here I have multiplication. Here's some more multiplication, and then I have addition. And so if I'm following rules of exponents, I deal with the multiplication first. And for logarithms, multiplication becomes exponents. So here, that multiplication becomes an exponent in the logarithm, x to the third. Here, that multiplication, that times 2, becomes an exponent inside the logarithm, so it becomes 3 to the second, which is 9. Okay? Now I can deal with that addition, and again, for logarithms, addition becomes multiplication. So addition becomes multiplication inside the logarithm, so it's log base 2. That's going to be of a 9x cubed. And that's it. And so we took something that had a bunch of different parts, and now we've condensed it into one logarithm, one thing, and that's going to allow us to simplify quite a bit in terms of some of these examples, and that's going to lead us to solving eventually. If we look at this one, same kind of thing. Order of operations inside the parentheses here. Multiplication becomes an exponent. So that multiplication becomes an exponent inside here. So that's an x squared. Again, that whole thing is still in parentheses, so I'm going to do that addition next. And really, I can go ahead and deal with this exponent over here right now if I want to. So right here, this guy, this multiplication, is going to become an exponent. I can go ahead and deal with that on the next step. So inside the parentheses, addition becomes multiplication. That's a 5x squared. Out here, the multiplication becomes an exponent. So that's log base 3 of 2 to the third power, which is 8. And now I can combine these into one thing. This is subtraction. Subtraction becomes division inside this thing. So 5x squared over the 8. Okay? But notice, I had something that was a huge string of characters, and now it's one logarithm. Okay? Hopefully you can see the benefits of that as we kind of get into these more complicated examples. And then the expansion, once again, if we kind of combine all these skills together in terms of expanding, I could work backwards. I could split this thing back up into addition. And then I could rewrite this exponent. I could bring it back out as multiplication. and now that thing is considered expanded, okay? Again, it's not something that I would do very often, okay? Same thing here. We did the same thing with this guy earlier. This 5 comes out. I can rewrite it back as multiplication. And now, again, I just have to be careful in terms of this 5 applies to that whole logarithm. So it's going to apply to these 2 logarithms when it's all said and done. Okay? We left it kind of in this format before. If you want to distribute that, you could write it like this. And really that makes sense because when you think about the original exponent up here, that exponent applied to the 2 and the x, okay? And the other thing about expansion here is if you kind of applied that 5 to the 2 and the x, you might rewrite that logarithm as 32x to the 5th first, and that's going to change things as you go to split this thing back up, all right? So keep that in mind. That's the other thing that students really struggle with expansion is should I simplify first before I expand? Okay, and where do I stop that expansion then, especially when it comes to numbers? Okay, again, this is not nearly as important as being able to rewrite these as one logarithm. Okay, here's splitting it back up. This division splits back up into subtraction. And now here, this multiplication. Sorry, I'm kind of running out of space here. This multiplication I can split back up into addition. And then that exponent I can rewrite back as multiplication. And that's it. Okay? So again, properties, logarithms, it's just the rules of exponents, but in reverse. It's the opposite of the rules of exponents, okay? So rules of exponents, when you multiply, you add the exponents. When you divide, you subtract the exponents. When you raise it to a power, you multiply the exponents. And the rules we had here were, hey, if I have addition of logarithms, it becomes multiplication. The subtraction of logarithms becomes division, okay? The multiplication times the logarithm becomes an exponent inside the logarithm. Okay? And then keep in mind that, yes, we can use those rules in reverse. It doesn't happen often, except with that last one, taking that exponent back out as multiplication. All right? And there's not a whole lot of benefits to it. Most of the time, we're combining these into one logarithm. Okay? And so we want to think about the rules that way. Yeah, we can use them in reverse, but make sure you understand how to use the rules to combine these things.